All right, hello. We're Unit 2, Day 3. We're going to be talking about angles inside of a circle. So just a real quick reference on angles. Remember that in a circle, all the way around is 360 degrees. Terrible drawing here, but 360 degrees around a circle. And if you think about making an angle inside of that circle, if I go to the center, if you split that into four equal parts, you got yourself basically four right angles because 90 times 4 is 360. And you can make those smaller and smaller too. So basically we talk about properties of these angles. We're going to start with central angles because those are pretty straightforward. That angle measure right here is equal to, we call this an arc. So the measure of that arc is the same degree as that angle. So, if this is a 100-degree angle, then that arc's going to represent 100 degrees around that circle. So we're just going to say the measure of the angle, or just angle, equals arc. So how you do these problems, if you see this little curve there, that's talking about the arc. The little m means measure of that arc, which means we want to, anytime you see the m, you want a degree, okay? Always want a degree. So arc AB, that's this part of the circle right here. That degree around all the way around the circle is 360, but that degree represents the same measure as that angle. So that's just going to be 100 degrees. Okay, yeah, I actually have to do anything for that. It's right there. If you look at this circle, this angle here is 40. So this arc right here is going to be 40. Now, if you notice here, this says measure of arc ACB. Not AB, but ACB. And the way that works is you go around the circle, starting with A. This is called a major arc because it's more than half the circle, by the way. Go through point C and go all the way around until you hit point B. So it's the other part of the circle. So if the whole thing is 360 and this part of it's 40, the answer for this is going to be 360 minus 40, which is going to be 320. All right, next example. So you've all seen the pie charts before. You use these a lot in statistics classes. Let's read the prop. The accompanying circle graph shows how the Marino family spends its income each month. You'll notice this is broken down in percentages. And so the larger the percentage, the bigger the pie piece, the wedge is going to be. So a big chunk of it's the mortgage. It costs a lot to buy a house. The auto, utilities, food, and insurance. And these are all percentages. A couple questions to answer in regards to those. The first one, it says, what's the measure in degrees? I want to know degrees of the central angle. Central angles are these angles in the middle. That represents the percentage of income spent on food. So we know that percent is 25%. But we want to know what degree that is. So we want to find 25% of 360 degrees. 25% of 360. When you do a percentage, 25% as a decimal can be converted to 0.25. We basically take the decimal and move it to the right 2 spots. And then that comes a number, 0.25. What we do with that 0.25 is we just multiply it by 360. So that'll get you the degree of just that part. And it's basically a quarter of 360. So if you think about dividing 360 by 4, what do you think that's going to get you? That's 90 degrees. That's that same thing that I drew right here. See? So that's a quarter of the circle. That's 90 degrees. There's your answer. If part B, if the Mario family spends $1,200 a month, how much money does his family spend on utilities? So this is a total question, okay? We're not talking about degrees or we're talking about percentages of the total amount a month spent on. We want to know how much money of that is spent on utilities. So if you think about breaking that up, you could figure out all the total values based off the percents by taking the utilities percentages, which is 20%, and we could take 20% of this $1,200. So that's again 0.20. 20% is 0.2, so move that over, times 1,200. So when you multiply those together, one too many zeros, you get 240. That's money. So we're talking about $240. All right, so 90 degrees for part A, $240 for part B. All right, question 4. The circumference of the trunk of a tree to be decorated is 16 inches. So C equals 16. You have 9 inches of garland to wrap partially around the tree trunk. What is the arc angle of the trunk that you will decorate? So let's take a look at maybe the top view of this trunk. We got a tree trunk. Circumference all the way around is 16 inches. You have 9 inches of garland to wrap partially around the tree trunk. What is the arc angle of the trunk that you will decorate? Well, let's do 9. Pretend this is 16. If I go around 9, that's a little bit more than half, right? Out of that 16, let me go a little bit further. A little bit more than half. So it would be more, as a percentage, it'd be more than 50%. But what you can do on this one is you can say 9 inches out of the 16 total inches. So we're going to treat this like a proportion. Equals some amount of degrees. So this represents an angle as well. And I don't know the angle, but I do know that all the way around in degrees is 360. So we have ourselves a proportion. If we actually cross multiply, remember we multiply these together, and we multiply these together, and divide, you would get 16 times the angle equals 9 times 360. So that's cross multiplication. We always use those when we set up proportions to solve them. And then I can divide that 16 out, and then that gives me just the angle. So if I do 9 times 360 divided by that 16, should give something in a degree that we can use. So that says 202.5. All right. The next type of angle we're going to talk about are called inscribed angles. Inscribed means angles mean angles that are on the circle. So this angle right here is considered an inscribed. The degree is actually going to be smaller than the arc. It turns out that that angle is actually half the arc degree. So what we say is the measure of the angle, which is right here, is actually 1/2 the measure of the arc. So let's look at this problem. Our goal is to find the measure of arc AC. I had the angle, so 35 is the angle. It's 1/2 of the measure of arc AC. So if I were to solve that for the measure of arc AC, I would just multiply the 35 times 2. So if I times 2 to both sides, canceling out that 1/2, you're going to get 2 times 35. So that's going to be 70 degrees. So this is 70. 70 divided by 2 is 35. 35 times 2 is 70. It works both ways. You got a similar situation going on for part 6. Why don't you try part 6 on your own? See if you can at least get BA. You know, it's very much like this problem. BA is going to be twice as much as 40, so you would take that 40 and times by 2. In this problem, you got a little bit more work because it's not asking for BA, it's asking for BC. It wants to know this over here. You know, what is that arc? And, you know, in a circle is 360. Now you got this 175 that's going around here. You got this 80, and all that's left is BC. So if you think about this is what we're trying to solve, this plus that should add to what? What's all around the circle? That's 360. So if you add the 80 and the 175, put that in your calculator, see what you get. It should be 255. Then we can subtract that from the 360, minus that out. And you're going to get 105. So your arc here is 105 degrees. That's arc BC. Again, those are inscribed angles. They're drawn on the circle. They're simply half the arc. Okay, so we got some practice problems. I want you to see if you can solve these on your own. Take a second to pause the video and see what you can do and come back and check the answers. All right, welcome back. Hopefully you tried these problems out. We're going to go through and check 7, 8, 9, 10, and 11. I may need to use some extra space to work them out, so please feel free to use extra paper. You know, I don't want you just trying to squeeze everything in here if you don't have the room. So we'll start with number 7. Our goal is to find this angle here. I like to kind of draw that angle and highlight it. So that angle actually, we call it intercepts this arc AC. If you see this angle right here, the endpoints of these sides are A and C, and it's also representing the endpoints of the arc. Now, if you look carefully at the other angle, it opens up to the same arc. Okay, so because this angle and that arc this angle and that angle share the same arc, it's going to follow that these two angles have the same measure. So in fact, x is just going to be 81 degrees. The arc's going to be twice that, but when you divide by 2, you get back to 81. So that's all there is on 7. On question 8, the angle that's drawn on here is a central angle. That's actually equal to the arc. The angle we want is the inscribed angle. That's half the arc. So once you bring that over there, then you're going to take that 48 and divide by 2. And so x will be 24. All right, question number 9. You have the arc. You want to get the angle. So this is going to be, the angle is half the arc. So if I take the arc and divide by 2, I get the angle. So it's going to be 124 divided by 2. So that's going to give you 62. All right, question 10, we want to know this arc here. And this arc, the endpoints of that arc form an angle back here that is a right angle. So a right angle is going to be 90 degrees. And that arc's going to be twice as much as that. So this is we call this a semicircle. It's halfway around. It's going to be 90 times 2. That's going to be 180. And that's actually half of 360. So there's your semicircle right there. All right, last question on these practice problems. We want to get this angle right here, which is the same as this arc, which also is intercepted by this inscribed angle here. So that angle is going to be half the arc. So I could double that. That's going to be 102. And that represents the arc. So that's actually a lot like this problem right here, except that we had the arc, so we divided by 2, whereas in this case we had the angle, so we multiply by 2. Just a couple more on here. I feel like doing all 3 of these is overkill, but I'll do at least the first one, maybe the second one too. We want to solve these for y. So these are actually talking about the angles here. Anytime you see that degree symbol, let's talk about the angles. And it doesn't say that these are congruent, but they open up to a third side of a triangle that happens to be the same. And these are all radii, radius, these are all going to be the same length here. So by default, if these 4 are the same length, these 2 triangles are going to be congruent by side, side, side. So these 2 angles are going to be congruent. So all I'm trying to say is set these 2 equal to each other. Set that equal to that. These 2 arcs are the same as these 2 angles. Set those 2 equal to those. Here, I'll set them up. This arc is the same as that angle. It's a central angle, so the angle equals the arc. Set those equal to each other as well. It's the same process, okay? So when you see these triangles formed from the center, and if they have the same angle in the middle, just set them equal to each other. So I'll work out one of these and give you the other answers. When you're working these out, you're solving the equations. I know you've done a lot of equation solving in the past, so I'll take you through this pretty quickly. This is going to be 5y minus 48 equals negative 47. Add the 48, that's 1. So that's 1 divided by 5, which is 1/5, or 0.2. All right, these two real quickly, let me solve these out. Pause it if you want to try them on your own. All right, I believe these are the answers: 1/5, 11/2, and 4. All right, we're going to talk about a couple other properties here. First off, if you have a triangle inside of a circle, if that triangle um, if one of the sides of the triangle is actually a diameter, then that's going to be 90 degrees. So if this is a diameter, that's going to give you a right angle. Same rules of inscribed angles apply. Quadrilaterals are pretty cool. These have a special property here. So all 4 angles in a quadrilateral add to 360. And this only works in circles. The opposite angles of a quadrilateral are actually supplementary. Remember what supplementary means? Remember they add to 180. So that's going to be a little bit different than parallelograms, because remember in a parallelogram, it wasn't the opposite angles that were supplementary, it was the consecutive angles. All right, those two added to 180 in a parallelogram. But you can't make a parallelogram in a circle. Look, it doesn't work. You can only at most get 2 points of that parallelogram on it. So it's not going to meet that same requirement. But what you will find is this. You'll find that this right here is supplementary to that. So this is 180 minus that. That number here is 180 minus the opposite side. So if you go across, subtract from 180, it works. Why that works real briefly is, without trying to take up too much of your time, you know that the angles around a circle add a 360, okay? Well, this angle, excuse me, the arcs add to 360. This angle is half this arc, and this angle is half the opposite arc. And so if you take the 360 and divide by 2, you're going to get 180. So the opposite angles are going to add to 180. So here's how that works. So for part A, and pay very careful attention to these ones require a little bit of work. I want to get the missing angle measures. I'm going to need to get this one anyway, but I'm going to get A, B, and C are both arc measures. And this is a quadrilateral inside of a circle. So let's start with A. A is opposite of 87. So A is going to be, these are supplementary. So A is going to be 180 minus 87. And I'll put that in the calculator and you're going to get 93. B doesn't just come naturally. You have to do a little bit of work to get B. So you might want to redraw this, or you know, write it in a different color or something. So the way B works is look at this 78 degree angle. And look at the arc going from the endpoints of that angle. So I'm including this 35 degrees and the B. If you ignore, so if I kind of cover up that, just kind of ignore all that, you have an inscribed angle, which is half of this arc, which represents B and 35. Okay? So this 78 degree angle is half of B plus 35. So what you want to do is you want to multiply 78 times 2. Okay, 78 times 2, put in your calculator. It's going to give you about 156. That's degrees. Then you can subtract the 35. So if you times the 78 by 2, the 156 represents all of that. Okay? So 156 represents all of that, and then if you take away the 35, you're going to get B. So 156 minus 35 is going to be, let's see, 9, 4, 14 minus 3 is 11. And so that's going to be 119. Okay, and the last one on this problem to get C, and I'm going to erase all this, so make sure you write it down. So I'm going to do B and C separately. You might want to use a separate sheet of paper for these. To get C, we're going to use a similar process. The only thing that we'll have to do is, I'm going to clear all this now, so get it down, please. You want to get C, sorry. In order to get C, you have to think about another arc to put with it. And then you have to think about the opposite angle. All right, so if you ignore all this, just like before, if I go through and just kind of white out all that here, and I focus on this. Now we had already gotten A. A was, let's see if I can reset that. A was 180 minus 87. So A was 93, right? So what I know is that 93 is 1/2 of C plus 35. So again, what I want to do is I want to multiply by 2. And after I multiply by 2, I want to, that's going to be 186. I want to subtract that 35. And that's going to be 151. So arc C is 151. So you got 151, 93, and let's see, 78 times 2 minus 35. So that's going to be 156 minus 35. What did we say that was going to be? 119 or 121. So we got our 3 answers. Excuse me. All right. Letter B. Now a couple more on this page and we're almost done. This one is, we're talking about triangles, so triangles are a little bit less work. We'll start with letter A. Look at this 32-degree angle. That's inscribed. That's half of A. You don't have to worry about B and C right now. So A is going to be 32 times 2, which is going to be 64. All right, boom. Got that one. Letter B, I don't have, if you look at the angle that it is, that's actually an angle I don't have yet, or an arc I don't have yet, because that opens up down here. I don't have this, but I can get it because I know that this arc plus that arc plus this arc, which doesn't have a label, should add to 360. So this is going to be 360 minus the sum of the 122 and the 64. So that's 360 minus 186. And that's going to give you, so 180 minus 6 is 174. So now that I have the arc, I can get the angle by dividing by 2. And that's going to get you 174 divided by 2. Oh, I'm having a brain fart, so I'm just going to put it in here. Too much mental math. It's going to give you 87. Now you can get angle C by dividing the 122 by 2, or you could add these together and subtract from 180. I think it'd be a little bit less work to just take this 122, since that opens up opposite of angle C, and just simply dividing that by 2. It's going to get you 61. So B is 87, C is 61, A is 64. You can check these 3 angles. They should add to 180. All right, examples, letter C for example 15. We'll start with letter A. Guess what two angles are going to be the same measure? Look at A and B. This angle here, anytime it looks like that, the tip of the M's, I should say, if they open up to that same arc, it's going to be the same angle measure. Now, these angles aren't going to be 76 because they're inscribed. They're on the circle. So they're going to be half of 76. So both of these are 76 divided by 2, which is going to give you 38. Now we had this little angle C here hanging out. A couple things about angle C. These are vertical angles. So I know that those two are congruent. And I know the three angles inside of a triangle, they're always going to add to 180. So if I combine these together, that's going to give you 90. See, 8 plus 5 is 13. 103. Double check my math, please. And if I subtract the 103 from each side, you're going to get yourself let's see, 180 minus 100 is 80, minus 3 is 77. So letter A is 38, letter B is 38, and letter C is 77. That's that angle in here. And by the way, this angle right here, what do you think that's going to be? That's 65 would also be there too. So hopefully you understand these, and I know there wasn't a lot of space to work them out. So again, use separate paper as you need when you're working on your notes. All right, last example. It's just a long video, but hopefully it helps you understand the material in this lesson. Example 16. 16 examples. We want to take this quadrilateral. Okay, what do we know about opposite angles? In a quadrilateral inside of a circle, opposite angles are not congruent. They are supplementary. So get it out of your head for a minute that you set them equal. You don't. They add to 180. Okay? So let's talk about what the opposite angles are. A and C. So these two together add to 180. B and D. They add to 180. So if I label, I got a 4x plus 12. B is 6y plus 10. C is 80. D is 50. Okay, see, 80 and 50, that's 130. There is no special relationship between these consecutive angles. It's all about the opposite. So let's start with x. Here's what I know. The opposite angles, A and C, add to 180. So if I do 4x plus 12 plus 80 equals 180, I can solve that for x. Combining like terms, you're going to get 92. So 4x plus 92 is equal to 180. Subtracting out the 92 gets you 88. And then dividing by 4 is going to get you 22. And y is no different. So try to set up y on your own, by setting b and d equal to 180. You might want to pause the video to try that on your own. and then see if you got the right answer for y. And you will have bared with me and watched all of this video, pausing along the way. It's going to take you pretty much the whole class period, but at least get the notes down. So that's going to be 6y plus 60. We combine their like terms again. Subtract the 60 from each side. And divide each side by 6. So y is 120 divided by 6, which is going to give you 20. Whew. I'm exhausted. I'm sure you are. Thank you for sticking with me. I know there's a lot of work. This is one of the longest days you probably ever have for this unit, but for this lesson. Unit, excuse me. See, I'm even delirious right now. But anyway, you have enough examples now where you can go through the day 3 assignment and get started and get working on those. We'll check it when we get back to our next class. You have a great day, and thanks for watching.